All right, Mr. Claxton's Algebra 2 students, we are going to apply the standard normal distribution and z-values today. And why are we going to do this? Really, we're going to do this to calculate probabilities, and that's not something we've spoken a lot about to this point, is using this to calculate the probability that someone or something at random is chosen. So the goal of this is for us to use z-values. You should know the formula for z-values. If not, you can look at this presentation in the notes. It should be in your notes. So, and I think I have it on the chalkboard there if you would like to look at it. So just a real quick note again about determining the probability of a randomly chosen sample. This is from the book, and it does a pretty good job of bridging that gap between z-values and probabilities. So we can actually use the area underneath the curve to make a prediction. We use that area as a probability that a randomly chosen sample happens. So it's a neat thing with statistics. It allows us to make inferences and predictions. So the examples that you should have out right now, and if not, then maybe you could pause the video and get them out. Example 10. We were on 10C, and the goal, what I wanted you to do yesterday, and maybe directly after class if you had a study hall, is get an area shaded based upon the information you've been given. So what is the probability that a randomly chosen male has a cholesterol level between 150 and 160? And these aren't nice values. We can use the empirical rule to estimate them, but only to estimate. I have a little recipe over here, and there are two different ways to do it. You can use your calculator. Calculator has a function called the normalcdf. You get to that by pressing second vars. But either way, you have to have this drawn out first. And so looking at that next slide there, again, well, that's the empirical rule that you could use to estimate it. So what would we do? Well, the first thing we did was calculate our z-value. We have a leftmost z-value of about negative 1.26. Notice how I rounded to the nearest hundredths place. We have a right z-value, that's the red one here, of 0 and 26 hundredths. And we want to find the area between them. And, you know, to do this again on a calculator, if you do have your calculator out, you might try to press the second button and then the vars button. So just, you know, real quick, second, and then vars is right under the arrows here. And when you do that, you're going to be given an option. You want to select option 2. We never want to select normal PDF. Right now, we just want CDF. After you hit enter, you'll probably see like -1e to the negative 999th power or something like that. And that's just a really low number, a number that's very, very negative, we'll say. But for your lower limit here, we want our leftmost z-value, which is negative 1.26, our rightmost z-value, which is 0.26. For this sample, we're keeping the mean at 0 because we're using z-values. You cannot use z-values and enter the mean of the data set, but we're not going to do that. And then the standard deviation would be 1 for this because we're using that standard normal curve and because we're using the z-values. When you hit paste, it'll actually paste it in on the screen. Now, if you would happen to not have a color edition or one that gives you the prompts, you would need to enter the values separated by commas just like here. Lower limit, upper limit, mean, and standard deviation. Okay, after you hit enter, it will give you that probability. It'll give you the area under the curve. Now, if you do not have a graphing calculator, then you are going to need to use a nifty little table. And even if you do have a graphing calculator, I do want you to pay attention. One, because, you know, hey, this is how they had to do it back in the day. You know, you have a probability sheet. You want to find the negative side of that, the negative side. It's got the negative values on the left-hand side. And we would need to find this negative 1.2, and then we go over until we get to 0.06. The value that we're looking for there is 0.1038. Now, that is the area to the left, and only to the left of, if you look to the left here, to the left of negative 1.26. That's only this area right here. That is only this area right here. And my pen isn't working. There it goes. That's only that area. So how in the world are we going to find the area between them, the gray area right there? Well, we'll have to actually look up the probability for this z-value, the right z-value. When we look that probability up, we'll need to go to the positive side. So now we're on the positive side. It has more shading up here and positive values. We go down to 0.2, over to 0.06. We see that's 0.6026. Now, we go back to the picture here, and to the left of that, if I were to color that in red, here, you know, that would be the entire area to the left of 0.26. Now, we could just subtract that red area. We're going to take that red area, or the probability, that red probability, 0.6026, and then subtract the black area here. So when we subtract the black area, we will have that desired, we'll call that our desired shaded region that we've set up right here, which is about 49.9%. You get 0.4988, 49.9%. I hope you were able to follow along with that. If you're using those tables, just remember, if you are calculating the area between, then you will need to subtract. And I say right probability minus left probability. And so I have a little cheat sheet there posted to Canvas if you need that. Or you could use your calculator. Looking at example D, in example D, and I'm going to refer back to that Z chart. In this example, we're going to calculate the area less than a Z value. Now that makes it pretty easy. We don't have to use any subtraction for this. This is the easiest. But the first thing that we need to do is calculate the Z value of what we've been given. We've been given this number right here, 145. So we've been given that 145 value, and we want to plug that in to our Z-value formula in order to calculate that probability. What is this probability? It's a very, very small one because we get about negative 2.02. So the area underneath the curve to the left of that is about 2.2%. Now, you would probably be able to estimate this. Some of you know that, you know, left of the -2 standard deviations is 2.5%. For some odd reason, my pen is not working as well. So please excuse this third grade writing. Boy, is that awful. I think my children can write better than that. So anyway, we know that's 2.5% to the left of that standard deviation there, that second standard deviation, or to the right of the positive, would be the same thing. And we know this is just a little bit less than that. So this should be about 2.2% of That is the probability that a male has a cholesterol level less than 145. I really do need to give props here to the word problem, and I should be using units to better understand it. Now for this last one, well, if we're using that Z table, what we need to understand here is that the area underneath the normal curve is 1. So if that area underneath the normal curve is 1, if we're trying to calculate the probability that a randomly chosen male has a cholesterol level over or greater than 155, we are going to need to first find the z-value. We plug it into the z-value formula. 155 minus 158.3 divided by the standard deviation of 6.6. We get a z-value of 0.5. Now, once we find that z-value of 0.5, we would find a probability associated with that. Now, when we find that probability, and I'll go ahead and find 0.5, so I come down to 0.5. You can't see it there, but it is 0.6915. And that only gives me the area to the left of that. So I want the area to the right of it. And the area to the right of that could be found by subtracting from 1. So 1 minus 0.6915 would give us the area to the right. And I cannot stress the importance enough. I was in a hurry. It is extremely important that you draw this out before calculating those probabilities. Draw out and shade the probability that you are trying to find. And again, that is in the notes. It's on that cheat sheet of what you need to do. Just so we can all be on the same page here. This is what I'm talking about with the cheat sheet. And this is posted to Canvas for you to refer back to. Just gives you the recipe, right? Not that I'm really into recipe learning. I would like you to learn more about the concepts and make connections in that way, but sometimes, hey, we just need the recipe. Outside of that, you should be able to work out worksheet B for 11-5, and again, you can replace this with Z-table instead of that normal CDF. That's what I showed you how to use today, so you could use the Z-table or the normal CDF. And the only other problem that I could foresee you having trouble with is number 5 on worksheet B, because there's a variable in the denominator here. And I know you're thinking, wait, you're going to make us solve an equation? Yes, you have to solve for sigma. One way to do that is going to be to multiply by sigma on each side. So if you multiply by sigma on each side, that gets it out of the denominator there and makes it a little easier to deal with. All we would have to do at this point is divide each side by 1.3. Now you got to make sure that if you are putting this directly in your calculator, for the one-stop shop, you got to put parentheses around that 21 minus 19, or you can just hit 21 minus 19, hit enter, and then divide by 1.3. So that should be helpful to you. I hope that this video was somewhat helpful. You can ask the teachers in the classroom, Miss Linden or Miss Moreland, questions. They can give you great answers and explain it to you if needed. All right, thank you very much.